So before we get into naming, we're going to need to be familiar with the different ways that a structure or a molecule could be shown to us. And all these different ways are showing the same molecule just in a different way. So the first way is kind of the way that shows us the most information. It's showing you everything laid out, all of the bonds, including carbon-carbon bonds, even hydrogen bonds, which is not usually shown. So this shows the bonds between each atom. Every single atom is shown in the structural formula. It's showing you exactly how that structure looks. And the names of these aren't too important to memorize at all, so I wouldn't focus on that. I would just focus on knowing that an alkane structure or any structure can be shown in these different ways, and we're just getting an introduction to this now, so when we do see these different structures, we're more familiar with them and we know what they're showing us. So this next one is showing this exact same structure, but it's not showing the individual hydrogen bonds. So now instead of showing these 3 hydrogen bonds, it's just written CH3 there. So it does not show the bonds between carbon and hydrogen. And then the next one is the line structural formula. This is the one that's most commonly seen in university chemistry, and we will see this a lot in grade 12 chemistry too. But in the beginning, you'll notice we see more things like this and this because we're just getting used to seeing molecules. And eventually we do look a lot at line structure formulas. So what are these? For these, every single end point represents a carbon. So all of those, but also every time you have a corner or an intersection. So right here would be a carbon, right here is a carbon, right here is a carbon, right here is a carbon, and there's a carbon. So that's the carbons, but then we also have hydrogens in this molecule, we just haven't drawn them. So if we wanted to see the hydrogens, for example, this carbon has 3 hydrogens that are not shown. The way that we know how many hydrogens should be there is that we need to remember that carbon forms 4 bonds. So it has the ability to form 4 bonds. So that's how I knew this carbon is already bound to one other carbon. So it has 1 bond already. So I knew that, okay, it's going to need 3 bonds to hydrogen. What about this carbon here? It's bound to 3 carbons already. So I know that it's going to have 1 hydrogen bound to it. And you wouldn't need to draw in all these hydrogens like I'm doing. I'm just showing you that they are there, but they're just invisible with the line structure formula. Next, we have the empirical molecular formula, which is just telling you how many of each atom are present. So another way of saying all of this, when you might not need to show the entire structure, you can just say C9H10. And then finally, the expanded molecular formula. So this would be good if showing branches is important. So these guys are like branches off of the main chain, but you're not taking up as much space as drawing out the whole formula. So you might see things like in this form as well, the expanded molecular formula. And so what it's showing you is anything that's not in brackets is part of the main chain. So we have CH3CH, which we see here, and then we see brackets CH3. What that's telling me is that that is a branch coming off of this carbon. So that's what we see here. And then we continue, so the next carbon is this one right here. And now I'm going to see another bracket to show that these 2 are coming off of that. So this is another branch, and then these final 3 carbons continue the chain. So that's another way of showing it. The most common ways that you guys will see it in your classes and on your tests are the first 3. And then we mentioned how the different formulas can come in handy when we're drawing structure. So just for review, C9H20, is that an alkane, an alkene, or an alkyne based on those general formulas we learned? So I see that, okay, the N is 9, and it looks like 9 times 2 is 18 plus 2. So the way that we got 20 was we did 2N plus 2, and we said that that's the formula for an alkane. So if someone was asking me to draw that, I knew I would have to draw out, just like we see here. Another way to draw that would just be writing out 9 carbons, 9, and then drawing in all the hydrogens. So that is an alkane having only single bonds. And you'll notice that the structure I drew and the one that's shown up here is different. And we'll talk more about that in a later lesson of how combining carbon atoms and hydrogen atoms can give us different structures. And that's why we need to have specific names for them. So I can call this structure a particular name, and you guys know exactly what structure I'm referring to. And you can see that if we just call them C9H20, even though I knew it was an alkane, I drew a different structure. So that's why the IUPAC naming comes in. So we can give each structure a name, and universally we can all be referring to the exact same structure.